Hello, my name is Charles Belser, and I will be demonstrating how I came up for the solution for the exam. So here we go. So, first of all, we had the first problem, and for the first problem, we had 1, 1, 2, and the goal is to find the non-duplicates. And I thought at first, well, because the lecture kind of gave us a hint on what we'd be using XOR, because if you XOR against itself, you're always going to have 0. And so I sort of thought, well, in this case, if we're trying to find the non-duplicates and you XOR duplicate against itself, then it's going to be, no matter what, 0. So we kind of can use that as like an indicator detector. And so I thought, okay, well, maybe if I go from one side to the other and I keep XORing, maybe, I could somehow determine the value for which number is not a duplicate. And so I thought if value is not 0, then it is not a duplicate. And so I would do A XOR B, which gave me 0, which, by the way, sorry for explaining, but I made the first number, the second number, and third number A, B, C. And as we go down these problems, I do use that method consistently because that's sort of what helped me get through this. So anyway, we did A XOR B, which is 1, and that in binary is 01, so these two right here. If I can grab that. So these two here. And so we got 01 XO 01, which is 0, right? And so now let's sort of go over here. And so we got 01 minus 2. Just because we're proceeding from this XOR to this XOR, and we're on this XOR now. And then that gave us 2. And I was like, okay. Then we make the variable that caused the value to be above 0 to be equal to the result. So now I thought, all right, let's try to make C equal 3 now in binary, because this is 3. Then XOR C with one of the duplicates. So B or A, basically, is what I'm saying here. Either way, the problem will be above 0, I guess is what I was trying to say. But yeah, either way, it would end up being this because, I mean, whether or not you use these two, it's a duplicate. It's going to be the same. So anyway, so let's move on to the next problem. And so I got 1, 2, 3, 2, 1. So a bit more numbers in the array here. So we got A, B, C, D, E for our variables. And let's just go from left to right again. So XOR, 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 XOR. And then I'll see right away that, like, okay, well, using these two problems, right? 1 XOR 2, right, is immediately going to give us 3 in binary. And that didn't work. So that quickly failed because it's, I mean, my theory that, the variable that would cause the result to be above 0 would be the culprit, which was wrong. Might have worked the first time because I got lucky, but didn't work this time. So let's try this again. So I have all of these numbers in binary, XOR 0 to each of them. So I said right here, how about if we XOR 0 with each number within the array? Spoiler alert, it didn't work. But I thought somehow that would be the solution, which it wasn't. Hence why I have these binary translations here, because I XOR'd 0 with each of them. And that didn't seem to work. So now that we have determined that this method would not work, I start storing R into itself. So, sort of like how I did with the first problem, where I would just sort of go left to right and I would XOR each time. Instead, I said, okay, what if as I XOR that result that I have, I would apply that and XOR the next variable in the ladder, okay? And I say it right here, XOR while keeping the result. And so, it begins. We have R XOR A, and for A we have 1, and 1 in binary is L1, so 0, 0, because our R is starting from 0, like how, you know, I started XORing with 0 here. So I go down, I XOR here, and I have O1, and then see R01 or 1, I make R equal that. And then I'm pretty much just storing that value in that. And then I go down the ladder, R XOR B, which O1 minus, or not minus, XOR 2 in binary. It's going to be 3 in binary. And then, as we go further, we're back to 0. And then we keep going until we get to the end. So, R XOR D, just 2. And then with 2 stored, we use 2 against the last digit, which is 1. Should be 1. It is. Right here. That's E. We started from here, and we made it to E now. And so 3 in binary is the final result. That's the last thing we got. It's the only reason why we've stopped is because this is the last one in the line. And now that we have nowhere to go, we conclude that this is our result, which is convenient because that turns out to be our answer right here. Okay, so we have this. Now let's apply it to future problems, right? So for our next problem that we're going to apply this to is we have A, B, C, D, E, and each time we're going to XOR, 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 and it's going to equal 4 at the end. Okay, so this R is 0 now, but by the time we get all the way down to here, R should be 4 for our result. So, step 1, XOR each R to each variable and store the result into R every time. So R XOR A, so 0, 0, 0, XOR 4 in binary. And then now we go down, R XOR B, and our second digit is B, should be 1. So B, so 4 minus, or 4 XOR, sorry, when I say minus, I mean XOR. I know it's not the same thing. I just want to put that out there. I mean XOR. So 4 XOR 1 in binary is going to give us 5. And then we store that into R. And then we bring R down. And we R XOR C. So that's going to be 5 XOR 2 in binary. And that's going to give us 7. So now R is 7. But like we've seen before, how we went from 1 to 3 to 0 to 2. So it doesn't really matter how high or low the value is going, as what matters seemingly is the final result. And so we go all the way down. We have 7 in binary, XOR 1 in binary is going to give us 6. So now we store 6 in R, then we bring R down, and then R XOR E. So 6 XOR 2 is going to give us 4. We store 4 in R. And now, that was the last one because E was our final variable. Okay, and for our and we already XORed the final variable, which we ended up was 4, which is the final result. So great, we figured it out. This is amazing. I was actually pretty surprised. I was like, what? Now that we went through each variable and XORed it, while storing it each time, we see the end result matches the answer. And so, throughout the rest of this, I have a piece of code here, and as you can see, so I have an array that I use here. It's an array that is being created during its runtime, and what I'm doing is I enter the amount of numbers into the array. So basically it starts with the size, and this becomes the size. This is the size of the array that it's going to be. and then the person inputs it, and then an array is created using that size, and it's just going to be called array. And then I create a for loop, and now this for loop acts as that transition that I have right here. So if I go up, or actually right here is perfect. So you'll see I have each of these variables, okay? Instead of using these variables each time to sort of identify which number it is along the ladder, I use a for loop instead that demonstrates, you know, where in the array it's going to be. So this I sort of acts as that. So this for loop ends when we get to the size. So the size that you originally entered, that ends up being the size of the array. So that's when it stops, when it gets to the end of the array, basically. And this basically tells it where in the array that it is at. So it starts off at 0, so integer 1, so I plus 1, which right now I is 0. It starts at 0, so it would be 0 plus 1, so integer 1. You're basically now the individual inputs that into the array. So basically this is each individual number. So let's say I had like a size 3 array, I put 3 here, and then this for loop is basically you're entering that many numbers into the array. And so you got, we'll do 1 1 2, like our first problem that we were given for the exam, right? So 1 1 2, right? And then this right here, this is our R. So that R that I showed you originally up here, basically this is going to act as that. So this for loop now is going to go through each variable that the variables that I used when I was writing it. Each number in the array, this for loop is going to go through each one, and each time it's going to XOR it, like right here, right? Or right here, right? And it's storing the variables each time. Now how it's doing that is, right, so just like this for loop's the same as this. So it's gonna give us our R, which starts at 0 originally, and then we got R equals R XOR array, and then that number in the array. So it's just going to do that. That I is which number in the array that is, that it's XORing. And then it does the XOR problem, and then that result becomes this. And then this basically outputs what that result was, so you can see it in real time. And then it does it again. It takes that R and it goes through the array and it does it again. And basically it's doing exactly what we did on hand here. And it's going down each time. And you'll see when I run the program, it looks very similar as it's going down. So I'll start with this problem. I'll put this into the program, and let's see if it matches this right here. So it'll be 1 3 0 2 and then 3. And then 3, of course, was our final result for this. So let's go ahead and run this program. All right, so now let's try this problem that I mentioned right here, right? So it's gonna be 1 2 3 2 1. So 1, or actually, sorry, how many integers do we want in the array? We want 5, right? So 1 2 3. So pretend like these numbers, it's like integer A, B, C. So 3, and then 2, and then 1. And then once we run this program, it should be laid out how I have right here. So I'll go ahead and write it down just so we have a side-by-side comparison. It should go 1 3 0 2, and then 3 again, and then 3 is what we should have at the end here. So let's run it. So we got 1 3 0, 2, 3. So perfect. So the number that is not duplicate is 3, because that's the final result, right? So this outputs basically once it's at the end, it reaches the end, it's done XORing while storing the values each time. This outputs that end result, and I guess so does this one too, right? They both do. And yeah, so that is what I have gotten. Let me go ahead and run these other programs that I haven't shown you yet. And let's go ahead and run this program again. 5, there's gonna be 5 numbers in the array. It's gonna be 4, 1, 2, 1, 2, and then 4, 5, 7, 6, 4, and end result is 4. And so let's see here. So as we go down this problem, I'll keep it at this view just so you have a side-by-side comparison. But we XORed. Our XOR A is where we start here, and that the first result is 4, just like on the program here. And then we XOR that while storing the value, and we end up with 5, just like the program. And then we go down again, and we do 1. We get we get 7, because we do 5 XOR 2 in binary, and that ends up being 7. And then we store that 7 into R, or result, and then 7 XOR 1, because that's the next number down, is going to be 6 in binary, just like the program. And as you can see, it all follows along. Let's go ahead and let's go down. Let's go ahead and do this one now. I did the math for this one too, or bit manipulation. That counts as math, right? It's logic. How many numbers do we want in the array? Let's see, 3, 6, 7, so there's 7. The result is 9, so the non-duplicate is 9, which, just like the answer should be, 9. And so as we go down, so it's 7, let's see, 7, 15, 8, 0, 9, 3, 9, and that's the result. So let's see, we got 7, right, 15, 8. Yeah, see how I got 15? Like, it was a big number. Like, when I got there, I was like, oh, didn't I do something wrong? But just trust the process as you go. Got 8, right? 8 after 15, 8 after 15, just like here. 0, 9, and then, okay, I did the wrong bit translation here, but that should be a 3. Because this in binary is 3, 1, 1. And then our XOR G is 9, so 3, 9. And then 9 is our final answer. And that is how we find non-duplicates within duplicates using bit manipulation. So, yeah. I hope that was good enough. Obviously feel free to message me if there's anything I could have done better. I will take that into my heart, and yeah, thank you.